So the next thing we're going to talk about what we call sinking funds. And sinking funds are going to rearrange the formula, the future value formula for your payment. And in the sinking fund, what you're doing is you're trying to establish the amount of money you need or the amount of money you need for a payment over future obligations or debts, to pay out future obligations or debts. And in particular, this is like when you do a retirement fund where you accumulate money all the time you're working, and then each month you're going to be paid a certain amount. So when we set something up like this, though, we're going to rearrange. Notice the formula that I rearranged where it just flipped, and this plus one that was up here earlier became a minus one. And now your payment is out here. We start up the future value. So parents decide to set up a college fund for their newborn. They want to have 100,000 in the account when the child is age 18. They plan to deposit money once each year on the child's birthday. So the first deposit is made on the birthday at the end of year one, which means this is a ordinary annuity. It's at the end. How much must they deposit into an account that pays 6% interest compounded annually to meet their goal? So this particular problem, let's go ahead and identify what we're trying to do. We need to figure out how much must they deposit into an account. So how much do you have to deposit means you're looking for your payment here. We want to find the payment. So what is PMT? And then they tell us that a couple other things. They tell us the future value needs to be $100,000. And then they give us the rate at which we're depositing, which is 6%. And then from there, we can know we're doing it annually. So because you're compounding annually, your M is equal to 1. And you're going to do this till the child is 18. So you're literally doing this for 18 years. This is going to be my T. So plugging into my formula here, here's what I get. I'm looking for PMT, the payment. The payment is equal to the future value, which is 100,000, times I. Well, my I is 0.06 divided by my rate divided by my M, which is 1, over 1 plus my I, 0.06 divided by 1, raised to the n power. My n is going to be M times T. So M times T, and T here is equal to 18. So it's just raised to the 18th power minus 1. So when we calculate this, here's how we set this up in our calculator. Notice that to calculate this particular value, we need to work this bottom part first. So that's what I showed right here. I worked the bottom part first. I carried my answer by using my answer button. And I'm going to take the top, which is 0.06, divided by the answer. And I'll multiply that by 1,000. And when I do that, I get my PMT, my payments that need to be equal to $3,235.65. And that's how much they have to pay yearly to make this work. So let's look at another one. This one says, an airline company estimates that it will need to replace a commuter jet at a cost of $26 million. So it has to pay this $26 million in 15 years. So this is your future value. And your T here is equal to 15. To have the money available, a sinking fund is established by making equal monthly payments. So we're going to make equal monthly payments into an account that is compounded monthly. So your rate R is at 0.058. And because your monthly payments, your M is equal to 12. And so when we calculate this, that means I'm going to get N now. My N will be equal to 12, the number of payments per year, times the number of years, 15. That's equal to 180. So when I set this up, how much should each payment be? I'm looking for PMT. So PMT is equal to the future value of the money, which is $26 million, times I. Your I here is going to be equal to 0.058 divided by your M, your R divided by your M, divided by 12, times 1 plus my I, 0.058 divided by 12, raised to the N, which is 180 here, minus 1. So let's go ahead and see how we work this in our calculator. Notice that when I calculate this here, I get, I do it a little bit differently. I work the inside of this first. I'm dividing this 0.058 divided by 12, and I'll raise that to the 180th power right here. It's equal to 3.562. Subtracted off the 1 and got 2.562. Then did this problem right here, this part again, 0.085 divided by 12, 0.058 divided by 12. And I divided that by the answer that I got down here. That gave me this number. And then I multiplied that by 26 million. When I multiply that by 26 million, I get a payment, a monthly payment of equal to $49,037.72.